Jai Shri Ram guys. Today we see about trees data structures. So in today's video we see about first three goals, and in next part of the trees basic video we see these three goals. So first of all, what is tree data structure? So tree is a hierarchical data structure, not linear. It is a hierarchical data structure where data is stored in form of child and parent. So let's more understand with example. As you see, this is parent. This is also called root. The first node in a tree is called root. But we more understand this in terminology part. But this is a tree data structure because data is stored in form of parent and child. Here one is parent and 2 and 3 are childs of 1. Similarly, 2 is parent for 4 and 5. So 4 and 5 are childs of 2. 3 is parent and 6 and 7 are childs of 3. So this is our tree data structure where data is stored in form of hierarchical form. So why we need trees? So trees are needed when our data is hierarchical like this, and we use trees when we want fast searching, these kind of things. More we see why we use trees in applications part. So now let's understand tree terminology. This is very important. So now first of all, understand what is node. So now understand what is node. So each element of a tree called node. So here 1 is node, 2 is node, 3 is node, 4 is node, 5 is node, 6 is node, and 7 is node. 1, 2, 3, 4, 5, 6, 7 all are nodes. Each individual element of a tree is called node of a tree. Root. The topmost node of a tree or topmost element of a tree is called root of a tree. When we do traversals, we do traversals from root only, because root we can access whole tree. So this is root of tree. Topmost element of tree is called root of tree. So the next is parent. As I already told you, this is parent. So the node above is called parent. So this is parent for 2 and 3. 2 is parent for 4 and 5. Similarly, 3 is parent for 6 and 7. So the next is child. The node below a node is called child of that node. So for example, 2 and 3 are childs of 1. 4 and 5 are childs of 2. 6 and 7 are childs of 3. So this is childs. So the next is our leaf node. So the node with zero children is called leaf nodes. So here 4, 5, 6 and 7 are leaf nodes because they have zero children or child, we can say. So the sibling. So sibling is the two nodes or two or more nodes with same parent. So this is 2 and 3 are siblings because they both have parent as 1. 4 and 5 are siblings because they both have parent 2. 6 and 7 are also siblings because they both have parent 3. So this is our siblings. So edge. The connection between any two nodes is called edge. So this is edge, 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 and this is edge. So edges are connection between two nodes. So the subtree. So the subtree is the tree inside tree. Like we see, this is a subtree. This is a whole tree, and this is a subtree. and this is also a subtree. If there are suppose more nodes, then this is also a subtree. Also, this node is a subtree of that tree. So subtree, as we study in maths, subsets. So here the small part of tree is called subtree. And descendant. So any node above is called ancestor of that node. And any node below is called descendant of that node. Let's see with example. So here one ancestors are no one because there is no node above that node. Two ancestors are only one. Four ancestors are 2 and 1. Similarly, 5 ancestors are the nodes above, which are 2 and 1. And 6 ancestors are 3 and 1. 7 ancestors are 3 and 1. 3 ancestors, ancestor is 1 only. So these are ancestors. So descendants. The nodes below a node is called descendants of that. So these all are descendants of one, and these two are descendants of two. These 6 and 7 are descendants of 3. So these are descendants. The node below are descendants, and the node above are ancestors. So the third goal of R is properties of tree. So there are mainly three. So the ancestor and descendant